Hey Marius, very nice to see and meet you again.
Hi, Fabian. Yes, nice to meet you.
Really appreciate you making time for this. I know it's a very busy period for you. Of course, today we're going to talk about all things data, AI, autonomous system, the automotive industry more widely. But just to set the scene, would you mind giving us a little bit of context to who you are and what you're currently doing at B Plus?
Sure. So, hi, my name is Marius. Thanks for having me here in your podcast. So, my background is basically in machine learning. I was at Audi 10 years ago. And what we tried to develop is highly autonomous driving. I was actually pretty early involved into everything around generating high quality data sets. So yeah, what it requires from a tool perspective, from also recording platform perspective, to get high quality labels for machine learning applications. And then I founded also two companies. The last one was Incenda AI, founded in 2019. We've done quality assurance for several automotive OEMs, but also other companies and startups in other areas like drones, for example. Actually, we've done always the same, ensuring that the quality for labeling is as per definitions, specifications, DD design. And yeah, 2 years ago, I made an exit with my colleagues. We sold the company and also the whole IP to B plus. B plus is actually known, I think, for logging solutions, hardware, software components for validation, verification purposes all around the world. But we are not only doing this, but also basic software development, for example, for camera, LiDAR, radar, ECUs. We are also into hardware in the loop solutions. And actually the core IP from Incenda, what you need for high quality data, was a perfect fit into that roadmap and infrastructure of B plus. Yeah, since Jan 2024, I'm the CEO of B plus Automotive, which is one of the entities of the B plus group.
No, brilliant. Thank you so much for the context, Marius. You mentioned a couple of important points that just for everyone listening to clarify. So you mentioned just to start ODD there. What's ODD and why is it relevant?
Yeah, sure. So ODD in my context is operational design domain. And that's actually very, very important. You can imagine, if you've never heard of it, looking top down into something. And whatever you see here is your operational environment. For example, a driving functionality like a lane keeping assistance systems should work in that environment. So you're looking top down into, for example, a highway situation, and maybe it's raining, or maybe you're inside roundabouts, or you're directly inside a city, and everything that makes this environment specific, unique, and has influence on your driving functionalities is relevant. And that's actually the ODD in a very simple way.
And thanks, Marius. That's super helpful. Another point you mentioned initially is on high quality data sets. What makes a data set high quality? What are the metrics that you look into?
Yeah. So I think first of all, it's a matter of context, because high quality does not always mean 8K camera images
Hmm.
and 99% accuracy on a pixel level, for example, for semantic segmentation labeling tasks. But it's actually more used to the point what it requires for your algorithm in the end to perform the use cases and actions it has to. So what we're doing is, on the first, we define the ODD, sometimes together with the customer, sometimes they have already something, and also specifications about, for example, the class sets you want to label or you need, and all these things around that. And then in terms of high quality, of course, you have to look into the sensorics and the data. For example, if you have like a high illumination in some areas, or the brightness has to be adjusted. So those are the basics. Sometimes you have also some system failures you will not have in your final data set. So these are, as said, very, very basic. And then in terms of labeling driven requirements, it's really about what kind of tasks you need for labeling. Like a detection task, then you may need 2D bounding boxes. is something more spatial, then you might need some semantic segmentation, for example. And then you dive into the requirements for quality metrics and KPIs. And here you have like F1 score and other metrics like map metrics, for example, to identify if the label was as per requirements. And if not, you of course have to put some work and effort in it to improve it. Or for example, if you have sequential data and you need some object tracking, it is very, very important that the IDs you assign to a specific object are stable over the whole sequence, for example. If you have some interchanges there with different objects, then your algorithm will have big difficulties to perform correctly if you put here failure data in your learning algorithm, for example.
On the topic of data labeling, just to get my sort of last introductory question out of the way, what are some of the data labeling is something that we hear a lot, that loads of organizations talk about, and lots of organizations that focus just on data labeling to support other larger players. What are some of the challenges that you see that currently automotive companies, whether OEMs or suppliers, face as relates to data labeling?
Yes, so I think the first thing is that it's a very price sensitive area. Of course, the OEMs and customers have to fulfill their monetary aspects. So that's one thing. The other thing is that also the labeling is still highly depending also on manual workforce. And then in the end, it's also difficult to manage all the workforce, also to have like ethic loans and stuff. So that's very, very important aspect. Then you have aspects like compliance to data regulations, for example, GDPR regulations, and you want to share the data maybe offshore with some labeling companies. That's also another aspect that is highly important. Also that, I mean, I can continue and continue and continue. It's about tool chains. It's about ramping up and ramping down. It's about automation. So, for example, you of course can use heuristics, classical computer vision algorithms. You can use AI to pre-label data. And of course, this might save some effort later in the manual labeling. Sometimes it causes more effort. That also depends a little bit on the labeling tasks. So I think the biggest challenge is that it's such a huge field. And if you start diving into that topic, it's really, really time intensive to build some knowledge and IP around it. And also being able to compare to labeling companies is very, very difficult because, I mean, imagine if you just have one image to label and you use that as ground truth and you send that image to three different labeling companies and say, hey, that's my specifications, that's my image, please label it. And you check the quality and compare against. It's about turnaround time, it's about quality metrics and stuff, but still, it's just one image. And of course, you can invest a lot of time for that image. If you want to solve that problem at scale and you send like 50,000, you cannot even compare those three companies because, I mean, you need dedicated tooling to investigate the quality and you have to build up a lot of workforce internally to do that. So, and that's a really big challenge. So besides from this diversity of different legal, financial and technical aspects, you also have to build up a whole tool chain and pipeline around it. And that makes it very, very difficult, especially if you are in pre-series development and you want to try out things very fast. You need some POCs, for example, for bird's eye view, which is currently pretty prominent outside. And so that makes it really, really difficult in the end.
To zoom out there a little bit, you mentioned tooling there. What does generally the data value chain look like, and what types of tool solutions do you currently see are quite popular or widely used as relates to not just the topic of data labeling, but also surrounding that in the wider enterprise landscape?
Okay, that's also a very, very broad question because, I mean, we could dive into like physical layers during data collection. And then you have to talk about, for example, ROS, which is pretty prominent in education and also pre-development. Then you have different middlewares as well. Then you have different labeling tool pipelines. I think in the end, you can really try to strip it down into 4 different key areas, in my opinion. One is the whole part of definition. So you are really sitting down, you're writing down requirements, the ODD definition, and the use cases for your, for example, algorithm and stuff. And then you have to think about data collection. So you need a dedicated pipeline beginning from the sensors you are selecting for your recording platform. And then maybe also you want to introduce some intelligent, smart triggering algorithms. So you need some kind of compute inside these vehicles, or you need algorithms that work on the edge. And if you have solved this, you need a strategy for ingesting the data, because imagine we have like something around 2 gigabits per second currently in common projects with a variety of 8 cameras, several radars, ultrasonic sensors, CAN signals, and of course LiDAR. So you might ingest something around 20 terabytes of data per recording vehicle per day. You need a strategy to ingest the data into your backbones, into your cloud environment, and then also to distribute it to the different departments for different machine learning tasks, for example. And then, of course, you need some kind of selection and curation of the raw material. You convert it into JPEGs or PNGs, for example. You divide it into, this is off-highway, this is highway, this is rural street, this is city, or into different use cases, like there is a pedestrian on the street, and then you make some subsets. Then you need the dedicated requirements, and you put all that together, send it to the labeling, and then into the quality assurance. Then you have like an iterative process behind where you identify issues during the quality assurance and solve the issues again back, usually in the labeling area. And then you forward the data to the machine learning teams and training pipelines, validation pipelines. And then you usually also have a feedback loop from what your neural network outputs. If it performs, for example, weak in certain conditions, for example, in severe weather conditions, your KPIs may be very bad. And then you get a lot of information about maybe you need some more raw material and you have to invest again into collection. Or maybe the clue about it is, okay, your model performs very weak differentiating between truck and van. And the problem lays maybe in the specifications. Maybe you have to introduce another class, or you have to reduce and combine 2 classes into one. So actually, as said, we have like 4 pillars, like defining, collection, curating, labeling, and then training. And for all of that, there are different tools outside, and most of the OEMs already have, at least at the key stakes, something available internally.
Alongside this process or these 4 stages, are there any particular technological developments in terms of current innovations that you see are very disruptive and particularly influential that currently organizations are interested in?
Yeah, so maybe what's very interesting for me is, for example, data anonymization. Of course, you need it. And of course, the first idea is to do it on the cloud. Why? Because you have compute available there. Then you have to deal with unanonymized images in the car, which is another topic. But still, I mean, at least when you ingest the data, then you can anonymize it. Problems getting more critical when you think that your collection pipeline should also work in other countries, in other areas of the country. For example, in America, it's a huge country with different states. Sometimes they have different regulations from state to state. And then, of course, we have like Asia, we have Europe, we have America, also with different regulations. And the requirements towards anonymization are different. But usually it's a good idea to have kind of the same recording platform and setup and toolchain in every state, in every country. So you have to like combine everything. And one solution would be to do anonymization directly in the car. Then you have different difficulties. For example, if you blur the raw data directly, it might not be that valuable anymore for your machine learning pipeline, right? Because you introduce some kind of blur in images, you get some patterns that are very specific towards those manipulations. And then your model might be trained on those manipulations and actually not on a face. That's a big deal. But what we can solve, for example, currently with other technology is we can get rid of that problem. For example, if we if we do an encryption of the storage in the vehicle, and you have no access to the raw image material inside the vehicle. So you collect everything, and on the storage, it's directly encrypted. As far as you put those storages out of the car, it's encrypted. Even if it gets stolen, or you ship the storages to your backbones and then you get rid of it, whatever, it's still safe in terms of GDPR regulations, for example. And so you can solve the problem of anonymization with actually another technique. And you don't have to anonymize with high performance algorithms inside the vehicles where you need a lot of compute, which is very expensive, for example. So those are very disruptive methods, I think, and also that you can nowadays manipulate the images. So you can swap faces, you can change faces, and you get rid of those artifacts and can also manipulate, for example, license plates. That makes it very, very easy because, you don't need a lot of contracts if you get unanonymized data or stuff like that. And it helps to keep your collection pipeline very clean. So that's one aspect. Also, other things are, for example, federated learning, which are interesting from my point of view, because also in terms of data security, you can directly train your networks algorithms on the vehicle, and you don't have to share the data, which is also pretty cool because, for example, I don't know, weights might have like 100 megabytes of storage in total. And you can share just those weights, and you don't have to share the raw image material, which is like 20 terabytes per day, for example. Yeah, but depends a little bit on the use case and what you really need.
Yeah, just on the topic of regulation there, one regulation that just given where we're located and also because it seems to be leading across the globe in a number of ways is the EU AI Act. I was just wondering what the implications of the EU AI Act are for you and your work with your clients specifically.
Also, a very good question. I mean, in the end, I'm pretty brave that the European Union has made such a progress in terms of regulation of AI. So that's a very upside, because I think it's not always the case that we are at the very front of AI development currently. And so in terms of regulations, we are a leader. Yeah, but it offers us a lot of opportunities there as well. So that's something that is pretty promising. Of course, I mean, I'm the CEO and I have to like fill out a lot of contracts, and I'm liable in the end. Also what the company, what our products and what my employees are doing. So for me, it's very, very important on the one hand to have regulations, but on the other hand, bringing all these information into the company, into the heads of our engineers, the responsibility as well, also to our product managers. And that's also not that easy. I mean, in the end, we still have people who say, okay, I'm building like hardware for, I don't know, sensor interfaces. So do I have to care about AI? Really? Is that important for me? I mean, in the end, yes, it will get important for you because it's such a disruptive technology and everyone has to deal with it in a certain way. So it makes sense to be like an early adapter to all these things and also try to bring in AI into our products. And then the EU AI Act is important for me as well. Yeah. But I'm not a legal expert. Also, if you have like specific questions towards that, I would also forward it to my legal, to be honest.
Another aspect you mentioned before was around data manipulation, hallucinations. A narrative that we hear a lot as it relates to autonomous driving systems and their development in the current day and age is around synthetic data and training models based on synthetic data, which is sort of a narrative that we hear a lot from people that usually are not so close to the actual development, is that there's no longer a need to send out these physical vehicles onto our roads to get real world exposure. I was just wondering what your take on this narrative is. What are some of the real world implications that you currently see, some of the challenges, and how it could potentially change some of the development timelines of autonomous driving systems?
So I've been at a conference a few days ago, and we've been talking about labeling and the services behind. And of course, it's one of our business models. Yeah. So and it's very important for supervised systems, where you like investigate into preparing data, labeling data, and then trading on that. And the guy said, "Hey, do you see a problem whenever the synthetic data gets more and more prominent and also more and more richer in terms of diversity? Because at least that's my point of view. That's the biggest problem and challenge currently with synthetic data, that the real world diversity cannot be integrated into simulation and synthetic data currently. And also, if you train your algorithms on synthetic data, you always lag in terms of applying it now into real world. So there's a big gap that is still not, I think, filled out. At least that's my point of view. And those are valid points, but in the end, I think it's very, very interesting for me to integrate simulation. For example, we also have hardware in the loop solutions where you like simulate for an ECU real world environment, but actually it's like in the data center, and you replay real world data you collected some days, weeks, months ago, and you calculate some KPIs around the driving functionalities and check if the ECU and the algorithm is working properly. So there, synthetic data is very, very important, because whenever you have like a closed loop simulation where you say, okay, again, bring the example of a lane assist. Whenever the lane assist functionality does not only make a sound, but also it operates the steering wheel, then you have like the closed loop, because you investigate, hey, I'm going into another lane, and you have to do some actions to resolve that issue, and it operates then the steering wheel, right? Or at least it has some I don't know, resistance against your driving idea. So there you need simulation, of course. And also I had some requests from simulation providers who said, hey, can you help doing quality assurance on our synthetic world? I mean, maybe you have played some games like GTA or whatever, and everyone has seen the person who is like walking very strange around and his feet is below the ground level, for example. So you also have bugs in simulation. That's also interesting. So for me, it's more like working together with simulation companies and solving all the challenges together, because I'm pretty sure that you will always have real world data at a certain amount and also synthetic data, and the combination of both is the gold. So for me, it's the other way around. I highly appreciate that synthetic data is getting more and more important, and we are now starting thinking about how can we collaborate to get better driving performance, for example.
Really, really interesting. Zooming out on the topic of sort of Gen AI more widely, are there any particular areas related to your words in terms of Gen AI applications that you're excited about that we may see over the coming 3 to 5 years?
Yeah. Yeah. So actually, one very recent thing is that we are using also like experts internally, and that helped us already a lot. Because, for example, you have some experts in certain areas, and it's within a company very, very important to transfer knowledge from A to B.
Hmm.
And especially in terms of nowadays, you have like mobile office and distributed teams all around the world. It's very, very difficult to spread knowledge, and having an expert available 24/7, especially as said, all around the world. Sometimes they're sleeping well, and you have some questions for it, right? You need the answer directly. So in terms of that, we create internal experts. We feed them in with a lot of information, and we have like some a very interesting approach about knowledge maps. So the problem with AI is usually that you have like some island or isolated knowledge, right? So you feed in, for example, everything about ODDs or ISO 27001, for example, and then it has that knowledge. In the end, it's important that all these different information you feed in is working together pretty well, and combining those islands with different bridges to make a system running. And here we investigate currently a lot to bring the experts into the position that they really can answer dedicated system related questions and not only sparse information. And I mean, there is a lot of progress currently outside using data on the edge as well. That's really, really promising for me. And I'm very happy that we have the technology already available because it helps us a lot in day-to-day business.
Just on topic, super fascinating. It's something I've thought about a lot. What you refer to as experts. Can you talk about what kind of technology you use for that and how you sort of started using it and intend to scale this? Given that this seems to be, from my perspective, holy grail. Given that at least I spend probably 80 to 90% of my day on Teams calls or Zoom calls, either trying to get information or make a decision. And these experts seem to be just technologically much better at that than I could ever be.
Yeah, you're totally right. I mean, early stages, we started with, for example, ChatGPT, OpenAI. There are others around there also good. I don't want to make some commercials about it, but we've started with it, right? And we played with it around. And the first idea was, okay, we create like a product manager, a very general one, which has all the product information from our company. Like you feed in data sheets and stuff. And if you have like a question for one of our loggers about the bandwidth, you will get the right answer, of course. The problems we had was whenever it gets to system. So we have like a logging platform and we have different sensors and we need a whole logging solution. And then it had started, for example, attaching like interfaces at the very wrong position. And it had really no clue about systems. And that was the problem we had. So as said, we now have combined those different areas of knowledge and islands with different bridges where we bring everything together. And then you have, it's pretty much like what we are doing in the quality assurance process. It's funny because you also do the same, like, and what we also have to introduce is like a feedback system where we can say, I'm using the expert as well sometimes because I have not everything in mind. And if I have a question related to one specific norm or standard, I'm pretty happy to ask the expert about it. And if I see, okay, that's a wrong answer, I can give like feedback to the system. And now the next challenge for us was that actually we feed in with new information and actually we have to test it. Right. Because who says that whenever we upload some new sheets, some new PowerPoints information, the answers we already verified are still valid? Same problems. I mean, you know about that probably. So we investigated into an testing expert to test our experts, and we worked out some knowledge base for this tester, and also some dedicated questions to specific expert islands and also to those bridges. And then it's very important to get good APIs for it, right? Because in the end, you don't want to copy paste questions, check for the answers of the expert, prompt it into another expert, evaluate that, compare it. So you will get rid of all these manual work. So, and then we started creating like APIs for it, connecting all these experts and making like a network of experts. But here we are still not ready. It's something we are doing in parallel to our business, but it looks very promising for us.
As a final question from my side, you've both personally, but then also as an organization, been really successful at responding to change, which naturally leads me to, and of course we don't have a crystal ball, but to the question of how do you think the business of B plus, specifically in your automotive domain, is going to change over the next 3 to 5 years in terms of business opportunities and clients and topics you work on, etc.
Yeah, so I mean, it already has changed a lot. So within the last, I would say, 2 years, especially in Germany, we've been working actually a lot with tier ones. And that has changed a lot during the last 2 years because OEMs are starting doing things on their own. And also some of the business models of the tier ones are not valid anymore because you go into, for example, zonal architecture for ECUs. So you do not need any more like, I don't know, 40, 50, 200 issues, but only like 20. So that changed a lot. Also, the business models in terms of revenue is changing a lot. For example, you sometimes now get paid per mile. and not for the development of ECUs and sensors and software. So there, a lot has changed for us. And it was not only working with OEMs in the automotive sector directly, but also expanding to related areas of business. For example, the off-highway market, which is not a secret, I think. Those will be the early adopters for fully autonomous driving. I'm pretty sure that this will come. So I think they got a lot of information and also research from the automotive area, but they can really use it now because America will lack of truck drivers within the next years. I think there are 1.2 million. I've heard from in the conference from Conti that there will 1.2 million people are missing for driving trucks in America. And you can really focus on, for example, the Sunny Belt, very specific areas, very close ODDs where you can already currently develop autonomous driving. And those will be the early adopters and they will get revenue pretty fast. So those are the areas we are currently also looking into and working together with new customers. But still, the automotive is still very, very interesting and also important. And we are ready whenever they are ready for autonomous driving.
No, thank you so much for your time today, Marius. I really appreciate it. Also really exciting to see how you're able to zoom into very technical details and then zoom out again, so very quickly into the wider macroeconomic context. And can't thank you enough. I learned so much from you today.
Yeah, thank you so much for the invitation, Fabian. I really liked it. And yeah, let's stay in contact.
For sure.